In this video, we will compare the Taylor series expansion of cosine and negative cosine. We begin with the dataset of cosine. So array formula, cosine of the x values, and negative cosine. So this is array formula, cosine of the x values. But because this is negative, so there is a negative sign. So this is the negative of cosine. Next, we generate the Taylor series expansion of both, which is the summation of a times x to the power 2n, where n is from 0 to infinity. And the coefficient a is equal to negative 1 raised to the power n plus k over factorial 2n. So this will be array formula minus 1 raised to the power the quantity n plus k. So n plus k divided by factorial 2n, 2 times n, and enter. And the value of k is data validation, list of items, 0 or 1. 0 if it is cosine, 1 if it is negative sign. Now we complete the Taylor series expansion. So array formula, series sum of the x values raised to the power 2n. That's 2n. So 2n raised to the power 2n. 2n starts from 0, incremented by 2. And the coefficient will be this range. Right now, because k equals 0, these are the same. Change it to 1. These two are the same. Then we chart this. Insert, chart, and we use scatter chart. We don't need this title. Okay. And we show the trend line. Series, trend line, polynomial to the 6th degree. For the label, use the equation. For the legend, position at the bottom. We'll go back to the setup. Use column A as label. Now that's better. And we go back to the trend line. The point size will be maximum. Except for the expansion, the point size will be none. But its line thickness is maximum. So here's the trend line and polynomial of positive and negative cosine. Next, we calculate the polynomial regression coefficients using LINEST. To do that, we complete the LINEST matrix, starting with the power. This will be transpose 0 to 6. And the elements of the LINEST matrix, array formula of the x values raised to the power 0 to 6. We have just completed the LINEST polynomial matrix. Now we can calculate the polynomial regression coefficients. So LINEST, starting with the cosine, data y and data x. For the expansion, LINEST, data y and data x. And finally, the negative cosine, which is LINEST, data y and data x, and enter. So let's compare Let's say at k equals 0. Then it's cosine. So 1, 1, negative 1. So that's 1, 1, negative 1. Negative 0.0555 plus 0.0555 x squared, negative 0.354 positive 0.354 x cubed, negative 0.147 plus 1.47 x to the, so we can reduce this, okay, x to the fourth, 0.117, negative 0.117, x to the fifth, we can adjust this, so x to the fifth, negative 0.0201, positive 0.0201, and x to the sixth, 1.07 times 10 to the minus 3, it's not showing, and negative 1.07 times 10 to the minus 3. If we change this to 1, then it is negative cosine. These values are the same, and their data sets are the same. Change this to 0, toggle this to 0, it is cosine. These values are the same, and the polynomial regression coefficients are the same. This completes the use of Taylor series expansion, series sum function, Linus polynomial regression to generate the dataset and trend line of positive cosine and negative cosine.